What if human evolution never happened the way we were taught? What if there is never a single line of ancestors slowly growing more intelligent, standing taller, and eventually becoming us? Imagine instead a world where several different kinds of ancient humans walked the same landscape at the same time. Some were small brain but powerful brain. Others had larger brain and lighter frame. Some made stone tools, and some may have used them to cut meat from animal carcasses. And at least one ancient bone suggests something darker still, that a hominin may have used a stone tools to cut flesh from the body of another hominin. On the eastern shore of Lake Turkana, beneath layer of volcanic ash, river sediments, ancient lake deposit, scientists uncover evidence of a world far more complicated than anyone expected. A world where evolution was not a ladder, but a crowded landscape of experiment. Different bodies, different survival strategies, different branches of human family existing side by side in time. This is Kobifora, one of the richest fossil landscape on Earth, and this is the place where the simple story of human evolution began to fall apart. Stand on the eastern side of Lake Turkana today, and the landscape feels more outwardly. The sun is relentless. The wind dragged dust across wide stretch of exposed earth, and dark volcanic rock lies scattered across pale sediment, while gullies cut through the ground like open wood. At first glance, it seems empty, but that emptiness is an illusion, because beneath your feet lies one of the greatest achievements of human evolution ever discovered. Kobifora is the part of the largest Lake Turkana basin in northern Kenya, a region where geology has created extraordinary conditions for preserving the past. Over millions of years, river changed direction, lake expanded and contracted, volcanoes erupted, and flood carried sediment across the land. Animals died near the river bank, and lake margins and their bones were buried. The stone tools were dropped and abandoned. Volcanic ashes settled over everything, layer after layer, until erosion finally began to reopen the archive. Wind and water slowly cutting through those ancient deposits and exposing fossils that had laid hidden for more than a million years. This is one of the reasons why Kobifora matters so much. A fossil on its own is a fragment, but a fossil preserved within a well-studied geological sequence becomes something far more powerful, because scientists can start asking questions on it. How old is it? What environment surround it? Which animals live nearby? What other hominins existed during the same period? Were stone tools present? Was the climate changing? Because the Kobifora Foundation preserve a record spanning millions of years, from the Pliocene into the Pleistocene. Because researchers can chase these questions for the span of deep time that include Australopithecus, the robust Paranthropus, an early member of our own genus Homo. The modern scientific story of the site though began recently. In the late 1860s, Richard Leakey began exploring the fossil-rich landscape east of Lake Turkana. The region was remote, field condition was brutal, temperature could turn extreme, and fossils were often scattered across enormous distance. But the potential was impossible to ignore, and the team began walking the explosion sediments, scanning the ground with practiced eyes. Fossil hunting here was really about digging into the earth at random. Often erosion had already done the first part of the work, and the landscape here itself revealed a fragment, a tooth here, a piece of jaw there, a section of skull, a broken limb bone. Most people could walk straight past these things without a second glance. But to a trained eye, a small shift in texture or color could reveal something extraordinary. And soon the discovery began piling up. Skulls, jaws, teeth, fragments of skeleton, stone tools, and the bones of elephant, antelopes, pigs, graphites, hippos, and carnivores. Kobifora was not revealing an isolated moment. It was revealing an entirely lost world. And inside that world, was a discovery that would change the way we imagine our own family tree. To understand Kobifora, you first need to understand that the landscape is the part of the story. The Eastern Turkana, what we see today, is not the landscape our ancestors would have known. Go back far enough, and you will see the world has changed completely. Lake level shifted dramatically. River system crossed ground that is bone dry today. Floodplain expanded, and vegetation swung between grassland and wetter, greener condition. The animals changed along with it, and hominids had no choice but to respond. Picture a group of early hominids moving through that shifted world. There is no road, no permanent building, no maps. The world is built entirely from memory, where water can be found, where predators gather, where stone suitable for tool making lies exposed, where a carcass might be waiting, where tree often shade, and where danger awaits instead. Survival depends on reading a landscape that never stopped changing. And that is exactly what Kobifora preserved. Not a single frozen moment, but a long, unbroken sequence of shifting environment and shifting lives. For scientists, every layer of sediment becomes a part of a much larger investigation. Volcanic ash is essentially valuable here because certain layer can be identified chemically and dated, letting researchers pin down the chronological relationship between the fossil and the archaeological site, almost as if nature itself has stamped a timestamp into the rock. Above a given layer, the younger, and below, older. Slowly, piece by piece, researchers began assembling the chronology, and that's when they ran into a problem. For generations, human evolution was told through a simple picture, a straight sequence, one creature following another. A primitive ape like ancestor gradually straightening, growing, and becoming more human until it became us. It was an attractive image, simple, memorable, and deeply misleading. But Kobifora helped tear that image apart. The fossil record from East Turkana hold records of multiple hominins form existing across the same broad stretch of time. The moment the reconstructed skull entered into the scientific discussion, it raises more questions than it answers. Its face was large and flat. Its brain case was bigger than expected for some of the early Homo fossils known at that time. Its combination of features simply did not fit relatively into a clean evolutionary sequence. Was there more than one species of early Homo living in Africa at that time? Could our early evolutionary steps have produced several related lineages instead of one tidy ancestral line? And that raises one of the most haunting questions in whole of paleontology. Did they ever encounter each other? We can't watch those meetings play out. There is no written account. But if different hominins populations shared part of the same wider region during overlapping period, it becomes hard not to imagine some kind of contract between them. Maybe they avoided each other. Maybe they competed indirectly for the same resource. Maybe they settled into different ecological niche entirely. Some interaction may have been peaceful, others may not have been. The fossil can't answer every question we throw at them, but they do destroy the illusion that there was ever only one kind of hominins walking steadily towards us. The human story, it turned out, was already diverse from the start. That question is the perfect place to leave things for now. A landscape crowded with different kinds of human, and we can't tell what happened when their path crossed. But bones only tells what our relative look like. They don't tell us what those ancient minds were capable of doing with their hands. So in part 2, we pick up from exactly where we left and put a sharp stone edge into an ancient hand for the very first time before following the evidence into something far darker. So until then, keep looking into the surface because the earth does not forget, it only waits.